Welcome to this in-depth guide on C-sharp delegates, a fundamental and powerful feature that is absolutely essential for any C-sharp developer looking to build robust and flexible applications. We'll explore how delegates empower your code. Delegates enable methods to be treated as objects, allowing for dynamic method invocation, flexible event handling, and powerful callback mechanisms. This capability is crucial for creating highly adaptable and responsive software architectures. They are essentially type-safe function pointers, offering a robust alternative to their C++ counterparts, but with the significant advantage of added object-oriented capabilities. This ensures both flexibility and strong compile time checking. Understanding delegates is absolutely crucial for building extensible and maintainable C-sharp applications, especially when you are designing flexible architectures that need to adapt to changing requirements. They are a cornerstone of modern C-sharp development. Let's begin our journey by exploring the foundational step of how to declare delegates in C-sharp. This is where we define the contract for the methods they will represent. Think of a delegate as a contract or a precise blueprint for a method. It meticulously defines the exact signature, including return type and parameters, that any assigned method must strictly match. This ensures type safety and predictability. You declare a delegate using the specific delegate keyword, which is then followed by its return type, the chosen delegate's name, and finally, its complete parameter list enclosed in parentheses. This syntax clearly defines its structure. For instance, the declaration public delegate void myDelegate defines a delegate named myDelegate. This specific delegate is designed to reference any method that accepts a single string argument and returns no value. This myDelegate can precisely reference any method that takes a single string parameter as input and returns nothing, indicated by the void keyword. It acts as a placeholder for such methods, ensuring signature compatibility. While delegates technically can be declared either inside or outside a class, it's generally considered a best practice to declare them outside, typically at the namespace level. This promotes broader accessibility and clearer separation of concerns. Declaring them outside ensures broader accessibility across your application and significantly contributes to cleaner, more organized, and more maintainable code. This approach enhances modularity and reduces potential coupling issues. Now, let's move on to the practical aspect of how we actually use these declared delegates through the process of invocation. This is where the delegate truly comes to life, executing the methods it references. After successfully declaring a delegate, the crucial next step is to create an instance of it and then assign a specific method that perfectly matches its predefined signature. This assignment links the delegate instance to the actual executable code. The method you intend to assign must strictly adhere to the delegate's contract, meaning it must have the exact same return type and the identical parameter list as defined by the delegate declaration. Any mismatch will result in a compile time error. You can assign a method using the new keyword, which explicitly creates a new delegate instance. For example, myDelegateDel equals new myDelegate clearly shows this explicit instantiation process. Alternatively, C# provides a more concise and often preferred syntax for assignment, allowing for direct assignment of the method name. For instance, myDelegateDel2 equals methoday achieves the same result with less verbosity. Once a method is successfully assigned to the delegate instance, you can then invoke the delegate just like you would call a regular method. Simply use the delegate instance followed by parentheses containing the arguments, such as del. You can also explicitly use the invoke method, which achieves precisely the same result as direct invocation. For example, del2.invoke is functionally equivalent and sometimes used for clarity or specific scenarios. Here's a complete code example demonstrating both the explicit new keyword assignment and the more concise direct assignment, along with their respective invocation methods. This provides a clear overview of the process. This example clearly shows how both the del and del2 instances of our delegate successfully reference methoday and then proceed to execute it, producing the expected output in the console. It highlights the flexibility of delegate assignment. Next, we'll delve into a powerful and highly useful extension of delegates, multicast delegates. This feature significantly enhances their utility by allowing a single delegate to manage multiple method calls. A multicast delegate is a single delegate instance that possesses the unique capability to hold references to multiple methods simultaneously. This means one delegate can trigger a sequence of actions, making it incredibly versatile. When a multicast delegate is invoked, it systematically calls all the methods that are present in its internal invocation list, executing them sequentially in the order they were added. This ensures a predictable flow of operations. You add methods to a delegate's invocation list using the convenient plus equals operator, which is syntactic sugar for delegate, combine. This allows you to easily append additional methods to be called when the delegate is invoked. Conversely, you can precisely remove methods from the delegate's invocation list using the dash equals operator, which is syntactic sugar for delegate, remove. This provides fine-grained control over which methods are executed. Let's now examine a comprehensive code example that clearly illustrates the practical application and behavior of multicast delegates. This will bring together the concepts of adding and removing methods. Initially, our delegate instance del is configured to point to method A, method B, and method C. This setup is achieved by first assigning method A and then using plus equals to add method B and method C. When del is subsequently invoked with a message, all three methods, method A, method B, and method C, are called sequentially in the exact order they were added to the delegate's invocation list. This demonstrates the multicast behavior. Following the initial invocation, method B is then explicitly removed from the delegate's invocation list using the dash equals operator. This action modifies the delegate's behavior for all subsequent calls. Subsequent invocations of del after method B has been removed will now only call method A and method C. This clearly illustrates how methods can be dynamically added and removed from a multicast delegate. An extremely important consideration when working with multicast delegates, especially for beginners, is how their return type behaves. This aspect can sometimes lead to unexpected results if not properly understood. If a multicast delegate has a non-void return type, it's crucial to understand that it will only return the value from the very last method successfully executed in its invocation list. All other return values are effectively discarded. Therefore, to avoid potential confusion and unexpected behavior, it is generally strongly recommended to use multicast delegates with a void return type. This ensures that the primary purpose is to execute actions, not to collect a single return value. Let's now transition to exploring some incredibly helpful tips and best practices that will enable you to effectively use delegates in your C# projects. These guidelines will help you write cleaner, more efficient, and more maintainable code. Tip 1. For ad hoc delegates, always prefer using the built-in func and action delegates to significantly reduce boilerplate code. These generic delegates cover most common scenarios without needing custom declarations. Func delegates are specifically designed and used for methods that are expected to return a value. Their type parameters precisely define both the input types for the method and the specific output type that will be returned. Action delegates, on the other hand, are specifically used for methods that perform an action or side effect but do not return any value, indicated by their void return type. They are perfect for event handlers or commands. Tip 2. Delegates can be incredibly effectively used for dependency injection, allowing you to inject specific behaviors or algorithms into classes at runtime. This promotes loose coupling and makes your components more interchangeable. This practice of using delegates for dependency injection makes your code significantly more flexible, highly modular, and considerably easier to test, as you can easily swap out implementations. It's a cornerstone of good design. Tip 3. It is generally advisable to avoid delegate.dynamic invoke unless late binding is an absolute and unavoidable requirement for your specific scenario. Its use often comes with performance and type safety trade-offs. Strongly typed delegates offer significantly better type safety at compile time and provide superior performance compared to dynamic invoke. They are the preferred choice for most delegate-based operations due to these advantages. Tip 4. It's crucial to know when to use events. When you are exposing a delegate as a public member of a class, always use events. Events provide a controlled and encapsulated way to manage subscriptions. Events enforce strong encapsulation and prevent external code from inadvertently overriding the entire invocation list of a delegate. They ensure that subscribers can only add or remove their own handlers, not replace the whole list. Remember, events fundamentally utilize delegates behind the scenes, acting as a wrapper. They provide a more controlled, secure, and idiomatic way to manage method subscriptions and notifications within your C# applications. Tip 5. Always handle exceptions gracefully, especially when working with multicast delegates. An unhandled exception in one method of the invocation list can prevent subsequent methods from executing. To ensure robustness, use getInvocationList to iterate through each method in the delegates list and handle exceptions individually within a try-catch block. This ensures that all methods are invoked, even if some fail. Tip 6. Cache delegates for optimal performance, particularly in performance-critical sections of your code. Reusing delegate instances avoids the overhead of creating new objects repeatedly, leading to more efficient execution. Caching delegates helps significantly avoid unnecessary object creation, especially when delegates are frequently created inside loops or other high-frequency operations. This optimization can lead to noticeable performance improvements. Tip 7. It is vital to understand the clear distinction between delegates and interfaces, as they serve different but sometimes overlapping purposes in C# design. Choosing the right tool is key. Use delegates primarily for single-method scenarios, such as callbacks, event handlers, or predicates, where you need to pass a method as an argument to another method. They excel at representing a single action or query. Opt for interfaces when you need to define a comprehensive contract for multiple related methods, or when you need to manage state and behavior across different implementations. Interfaces define what an object can do. Tip 8. Always adhere to the solid principles of object-oriented design when working with delegates to ensure you produce clean, maintainable, and scalable code. Delegates can be powerful tools for achieving these principles. Delegates can significantly help you achieve principles like the single responsibility principle by allowing classes to delegate specific tasks, and the open/closed principle by enabling new behaviors to be added without modifying existing code. Tip 9. Strive to minimize coupling in your designs. Delegates inherently enable designs with minimal coupling between components, as they allow for indirect invocation rather than direct dependencies. This makes systems more robust. This minimized coupling directly promotes greater reusability of components and enhances overall flexibility, making your applications significantly easier to adapt to new requirements and extend with new features over time. Tip 10. Delegates are absolutely fundamental to event handling in C#, forming the very backbone of event-driven programming. They provide the underlying mechanism for how events are declared and how subscribers respond. They allow you to define custom events and associate multiple event handlers with them, creating highly responsive and interactive applications. This pattern is essential for UI frameworks and asynchronous operations. By thoroughly understanding and diligently applying these core concepts and best practices, C# beginners can effectively leverage delegates to create dynamic, flexible, and highly maintainable applications that stand the test of time. This knowledge is invaluable. Keep practicing these powerful techniques and experimenting with delegates in your own projects. Through consistent application, you'll undoubtedly unlock new possibilities and significantly advance your C# development journey. Happy coding!